today we're going to talk about how to evaluate functions and some different ways of doing that and what might be an easier way of doing this. So when we're talking about evaluating a function, right, we're actually asking you to find the y-coordinate, right? When you evaluate, you're finding a y-coordinate for a specific x-coordinate. Right, so if we were creating a graph, right, we would maybe make like an XY table. We would pick some different x coordinates that we want to plot, and then we would plug those values in to evaluate them to find their y coordinates. Right, so for one example that we're going to look at today, we're going to evaluate f of 4 for f of x equals 5x to the 6th minus 19x to the 5th minus 2x to the 4th minus 3x cubed minus 16x squared minus 20x plus 15. Right? So what we're really asking to find, right? So what we're told here is that x is equal to 4, y equals what? So when you're finding f of 4, you're finding the y value. So y is equal to f of 4, right? And if we write that out, that is equal to 5 times 4 to the 6th power minus 19 times 4 to the 5th power minus 2 times, right? Just going down, we're replacing all of these x's here with the number 4. That's all I'm doing to evaluate, right? But this is a lot of writing, right? It's taking me time just to even write out what this is, and I keep writing x instead of 4, so then it's more writing because I have to erase my mistakes. Right? It's so long, in fact, that I needed 2 lines to do this. So now, I don't know what 4 to the 6th power is in my head, right? Maybe you do, but I don't. So I'm going to use my calculator. So what I'm going to do is slide my calculator on here, and I'm going to type this whole thing into one line. So I have 5 parentheses 4 raised to the power of 6, right? Minus 19 times 4 raised to the power of 5, right, minus 2 times 4 raised to the 4th, minus 3 times 4 raised to the 3rd, okay, minus 16 times 4 squared, minus 20 times 4 plus 15. Right, it took us a long time to type that in, and there's a lot of places for me to make a mistake, but my final answer is that it's equal to -1. Right, so all of that work just to find that f of 4 is equal to -1. Right, so a lot of places, I'm going to get rid of that, a lot of places to make a mistake on the calculator, right? If you type something in wrong, everything's going to be wrong, right? It's just a lot harder, right? So now I want to look at this. Let's look at some synthetic division, right? So, right, you've done a lot of synthetic division problems if you're this far in Algebra 2, so you're probably really good at this. So I'm going to set up my box and my table. Right, and I start with x to the 6th. So this is a longer synthetic division problem than you might have done. Right, so I'm counting down from power of 6 all the way to no x's. Oh my goodness, my pen does not want to work. Okay, so if I put the 5, -19, -2, -3, my pen really doesn't want to work today, -16, -20, and 15 in here. Right? If I go ahead and put a 4 into the box, which is the number that I've been evaluating with, if I go through and do my synthetic division process, right, I drop the 5, multiply, and I get 20. -19 plus 20 is 1. 1 times 4 is 4. -2 plus 4 is 2. 4 times 2 is 8. -3 plus 8 is 5. 4 times 5 is 20. Come on, Apple Pencil. Negative 16 plus 20 is 4. 4 times 4 is 16. Negative 20 plus 16 is negative 4. And 4 times negative 4 is negative 16. And when I add down, right, 15 plus negative 16 is negative 1. Oh, wait a minute. That number at the end, which is the remainder, right? Right? The remainder is f of 4. Okay, well that's pretty interesting. Let's try this for another problem. Maybe that was just a coincidence, right? We don't like coincidences, right? That might not be a pattern that holds true all the time. We're going to actually examine it for something else. If it holds true a second time for a totally different function, it's probably something that's going to work all the time, right? So scrolling down here, okay. We'll make it a slightly smaller problem. We're going to evaluate f of negative 3 for f of x equaling negative 3x to the 5th minus 7x to the 4th plus 10x cubed plus 12x squared minus 5x minus 8. Okay, so let's try it the long way first. All right, so f of negative 3, all I'm going to do is replace all of those x's with a negative 3. Now, when I have a negative value inside of here, my parentheses are super, super important, which means that if I don't type in my parentheses correctly, my whole problem's wrong. Okay, I can fit this all in one line this time. Whew, okay. Right, so we wrote it all down. That's what we're going to type into the calculator. So now I have to type it in really, really carefully. So let's clear this bad boy out from the last one. Okay, we've got negative 3 times negative 3 raised to the 5th minus 7 times negative 3 parentheses raised to the 4th. Right, notice that I'm being really careful to put my parentheses around that negative 3, and the exponent goes on the outside. Where's my plus? Why can't I see the plus sign button? Can I? Nope. Okay. Oh, okay. I had to write the plus sign in. Interesting. Obviously, I've never used this calculator before. Plus 10. Oh, my goodness. Oh, no. What did I just do? Oh, no. Okay. Back it up. Back it up. Let's try this again. Let's just split the screen with this. Okay. There we go. Now I can see the whole thing. We'll make that a little bigger. Okay. That's a little better. Okay. Where was I? Times 10. Plus 10 times negative 3 in parentheses raised to the cubed power plus 12 times negative 3 squared minus 5 times negative 3 minus 8. Okay, we get 7, right? But it was a lot of work. It was a lot of work to type that incorrectly, right? There were so many places where I could have forgotten a parenthesis, typed in the wrong exponent, missed a negative or a positive sign, right? There's a lot of places for mistake. So I'm going to close this out now, just to give us some more room. So now if we look at it with synthetic division, right, make my table again. We start with x to the 5th. This is my highest power, so I'm going to count down. Right, remember you don't have to label your columns, but they're super helpful in case you're missing a power. So now I'm going to put negative 3 in my box. I'm going to copy my numbers out of the problem, right, to set up my synthetic division table. So now if I bring down the negative 3 times negative 3 is positive 9. I add down to get 2. Negative 3 times 2 is negative 6. 10 plus negative 6, so 10 minus 6 is 4. Negative 3 times 4 is negative 12, so these are going to actually cancel out when I add. Okay, if I multiply by 0, I get 0, so if I add down, I'm going to get negative 5. Negative 3 times negative 5 is positive 15, and negative 8 plus 15 is the same as 15 minus 8, so hey, we get a 7 again. So this is actually something that always holds true. So function evaluation can take a long time, you can make a lot of mistakes, and if you don't have a calculator, figuring out all of those exponents is really hard because you're going to be dealing with a lot of really big numbers. So what we've actually been doing with this synthetic division is something called the remainder theorem. Now, of course, the remainder theorem, it's a math theorem, so right, the actual definition, the technical definition is a little bit more formal, it's got a lot of math words in it, right? We're gonna boil it down and make it really simple. What the remainder theorem says is that f of some number equals the remainder from synthetic division. Synthetic division. Right? So what the remainder theorem really tells us is that we can use synthetic division to evaluate functions, evaluate specifically polynomial functions, right? This is not going to work if it's not a polynomial. By putting the x coordinate or the x number in the box and then solving for the remainder. So we're going to do one more of these in action. I'm trying. Okay. So let's try one more of these. Right, so I guess I don't have to write example. We were on number 3, right? So I'm going to word it a little differently too, because you might see this wording as well, right? We're going to evaluate f of x, which equals negative 2x to the 4th plus 21x squared minus 12x plus 8 at x equaling 3. So the first thing I'm going to do to use my remainder theorem is, of course, I'm going to set up my synthetic division table. So now I want to be really careful here. So I'm starting with x to the 4th, and then I'm just going to count down. So I need to have x cubed in my chart, x squared, x, and then no x's, my constant. So when I go through and pull those numbers from the problem, right, I have negative 2x to the 4th, I have no x cubed, so I'm going to put a 0 in there. I have 21x squareds, negative 12x's, and 8 constants. And then whatever number is, if it's an x equals a number, unlike synthetic division where you normally have to flip the sign, if it says x equals the number, you put that number into the box. So if there's an equal sign, you don't flip it. If there's no equal sign between the x and the number, then you flip it. And then we're just going to do synthetic division. So I'm going to pull down my negative 2. Negative 2 times 3 is negative 6. If I add down, right, 0 plus negative 6 is going to be, negative 6. Negative 6 times 3 is negative 18. 21 minus 18 is 3. 3 times 3 is going to give me 9. Negative 12 plus 9 is negative 3. Negative 3 times 3 is negative 9. And adding down again, 8 plus negative 9 is negative 1. So that's what I'm looking for. So this tells me the answer, f of 3 is equal to negative 1. And that's the whole way that we use the remainder